Hello, everybody. Today we have a presentation on insertion sort. This is by Evan Airy.
And Callum Seamer.
Insertion sort is a simple algorithm that sorts the array by shifting the given element by one. It's one of the most simple implementations of sorting. It's very efficient for small data sets, but not very efficient for large data sets. It's also stable, which means it maintains the order of identical values, as well as in place, which means it's a variable. It has a variable that is used to hold variables that are being swapped. As you can see in the GIF to the right, it's just taking the deck of cards and sorting them in order from least to greatest. How does insertion sort work? It's a nested loop to iterate from array 1 to array x. It compares the current element to the element that comes after it. If the element that comes after it is smaller than the next element, then it needs to be compared to the element before it. Every element that is greater than the element before must be moved up one space to make room for the current element being swapped. An easy way to think about insertion sort is to think about sorting a random group of people into height order from shortest to tallest. So if these people were scrambled to your right, a great way to think about it was just putting them back in order and just pushing each person down the list until they're in order from greatest to tallest, or from smallest to tallest. Here's a short demonstration. First, you start with the first number in the list, and then you look to the number to the right. And since 5 is less than 6, you'll move 5 in front of it, move it down, and push over 6. And then since 3 is less than 6 and as well as less than 5, it'll move in front of both of them. As well as the same thing for 1. You'll look at it and you'll take it, you'll look, it's less than 6, as well as less than 5, as well as less than 3. So it'll go to the first part of the list. And then you move down again and you look at 8, and since 8 is greater than 6, it stays where it is, which makes you look at 7. Since 7 is less than 8, it moves down in front of 8, or in front of 6, and in between 6 and 8. And the same thing for 2. It's less than 8, less than 7, less than 6, less than 5, and less than 3. So it goes in between 1 and 3. And then you look at 4, the last number in the list, and it's less than 8, less than 7, less than 6, less than 5. So it goes in between 3 and 5 and makes the list be in order from least to greatest.
So then we get to the actual performance of this algorithm. So the worst case running time for an insertion sort is O to the n squared. This is for the comparison and swap. So when comparing two values, the worst runtime is going to be O to the n squared, and then the worst runtime for swapping is going to be O to the n squared as well. That's just because you're going to have to run through a for loop and a while loop as well. The best case running time, however, is O to the n for comparison, and O to the 1 for swaps. It can be the best running time can be O to the 1 for swapping, because you can have an array with only like 2 values in it, and the runtime will be the same no matter what. Or if the array is already in order, the algorithm won't have any work to do. And then you have your average case running time, which is O to the n squared for both comparison and swap. And for the best performance, you're going to want to use insertion sort algorithm, mainly just for sorting integers and smaller arrays. The only time you really want to use this type of algorithm is just when your data set is really small, because it's not very efficient with a bigger data set. But if you only have 10 integers in an array, you can really just implement this into your code super easily. It only takes a few lines, and especially it's very useful when a lot of the data is already sorted. So you can see here, if you have 1, 2, 4, 6, 3, and 2, all you really need to sort is the 3 and then the 2. Here's an example of what the code would look like. So you'd put together a function Here we have a function called insertion sort, which takes two parameters, an array and the length of the array. And you can see we have a for loop, and that for loop will start at the first element in the array, and as long as I is less than the length of the array, it will cycle through, and it will set an integer key to the array value at element I, and it will set j equal to whatever the index is minus 1, and it'll run a while loop that decides whether or not the array's element is greater than or less than. So basically it will compare the values and sort them accordingly. And once it's finished running through and it gets to I being equal to the length, your array will be sorted in order from least to greatest. So that's the pseudocode for insertion sort. And just to go over the key points, basically you only want to use this when you have a small data set and you're using integers. As you can see, as the data set gets bigger, it can take quite a lot more time to index through, causing it to have not a great running time. And it just sorts from the smallest value to the greatest, and it's a pretty simple and useful sorting algorithm that we hope you learned a bit about. Our sources were Geeks for Geeks, and we found a couple images and whatnot on Wikipedia. Thank you.